Hello friends, I am Aditya Halkadnikar from Walchand College of Engineering, Sangli. Welcome to the tutorial series of Basic Electronics Engineering of ELISA, means Electronics Engineering Students Association. We are going to learn about series voltage regulators. So we will start from the basics of regulator. A voltage regulator generates a fixed output voltage of a preset magnitude that remains constant regardless of changes to its input voltage or load condition and also external conditions like temperature. It generates a fixed output voltage that remains constant for, for any changes in input voltage or load condition or external condition. It acts as a buffer for protection of components from damages. A voltage regulator is a simple feed-forward design and it uses negative feedback control loops. So, now we will see the properties of regulators, that is line and load regulation. So, we will see the definition of line regulation. Line regulation is the ability of the power supply to maintain its specified output voltage over changes in the input line voltage. It is expressed as percent change in output relative to change in input line voltage. So, for example, for 780X series, the input voltage must be greater than the twice of the output voltage. The load regulation is the ability of power supply to maintain its specified output voltage given the changes in the load. But when the load changes abruptly, there is slight changes in the output of regulator, but this is due to the transient response. Remember that the line regulation is related to the input condition changes and load regulation is related to the output, that is load of a regulator. So there are basically two types of voltage regulator: linear voltage regulator and switching voltage regulator. Further, these are divided into series. Linear voltage regulators are divided into series and shunt. There are three types of switching voltage regulators: step up, step down and inverter voltage regulators. We will be seeing the detail of the series voltage regulators. We see the circuit diagram of series voltage regulators. This regulator is connected in series between the unregulated source and output regulated source. The amount of current drawn is effectively used by the load. This is the main advantage of the series voltage regulator. It consists of control element, reference voltage source, a comparator circuit and a sampling circuit. The series voltage regulator circuit block diagram is shown on the screen, which consists of input voltage Vin. There is control element and the output of the control element is the voltage, which is regulated voltage. There is circuit which feedback this regulated output. That is, we are feeding the output voltage through a sampling circuit through a comparator. This circuit is basically made up of different resistances, and this sampling circuit feedbacks a portion of output voltage into a comparator. Comparator means it compares the two voltages. The voltage which is coming from the output through this feedback circuit and other is the reference voltage. Here the comparator circuit, the output voltage is compared with reference voltage and then it drives this control element. The output of this comparator circuit drives this control element and this control element controls the output voltage to maintain it at a constant level. Now we are going to see the different kinds of series voltage regulators. They are simple emitter follower series voltage regulator and series voltage regulator with feedback. Now we will see simple emitter series voltage regulator. As shown in the figure, we can see the series pass transistor and a Zener diode. Now the circuit diagram is shown in the figure with the current and voltages. Here Vz is the voltage across Zener diode, Vb is voltage across base emitter junction of series pass transistor, RL is a load, Vin is unregulated power supply and Vout is the regulated voltage across the load. While I am telling the working, please take the note of every voltage and current to the specific point. Watch the current voltage diagram carefully. Change in Vb causes regulation of voltage across load. Remember the equation. According to the KVL, VBE is equal to Vz minus Vout and Vout is equal to Vz minus Vb. These are the governing equation for the constant output voltage. Now, let the supply or input voltage increase which will cause increase in the output voltage Vout. An increase in output voltage Vout will result in decrease of Vb because Vz is fixed and decrease in Vb will reduce the level of conduction. This will lead to increase the collector emitter resistance of the transistor, causing an increase in collector to emitter voltage, and as a result the output voltage will be reduced. Thus output voltage will remain constant. Similar explanation can be given for a decrease in supply voltage. Now let us consider the effect of change in load on the output voltage. Say current is increased by decrease in RL. Under such situation, the output voltage Vout tends to fall. Therefore, Vb tends to increase. As a result, the conduction level of transistor will increase, leading to decrease in collector emitter resistance. The decrease in collector emitter resistance of the transistor will cause the slight increase in input current to compensate the decrease in RL. Thus, output voltage being equal to IL into RL remains almost constant. Similar explanation will hold true for increase in RL. Advantage of this circuit is to provide more stabilized output than regular Zener diode regulator. The output voltage cannot be maintained absolutely constant because both Vb and Vz decrease with increase in room temperature. Further, Vb increases slightly with increase in load. Also, the output voltage cannot be changed as there is no provision for it in the circuit. It cannot provide a good regulation at high current because of small amplification provided by one transistor. Due to the given disadvantages, we go for series voltage regulator with feedback. Now, we are going to understand the series voltage regulator with feedback. Watch the current and voltage carefully in the diagram to understand the working and equation of this regulator. Now consider case 1. Output voltage increases. Say for any reason the output voltage increases. As a result, the voltage across KL, that is R2, increases. This in turn means more VF is fed back to the base of transistor Q1, producing large collector current of Q1. This causes base voltage of Q2 to decrease. As most of this collector current flows through R3, hence we get less output voltage. In other words, the increase in voltage is offset, keeping output voltage constant. Output voltage decreases. Say for any reason the output voltage tries to decrease. As a result, the feedback voltage VF also decreases. Hence, the current through Q1 and R3 also reduces, which actually means that we get more base voltage at Q2 and thus more output voltage, consequently keeping the output voltage at the original level. Now we will derive the equation for the output of series voltage regulator with feedback. So, series voltage regulator with feedback. The voltage R1 R2 resistor divider provides the feedback voltage. Then we write the equation of feedback fraction M. So we have derived the equation of M as R2 divided by R1 plus R2. The feedback fraction is the inverse of closed loop voltage gain. We find output voltage as shown in the derivation. Study carefully the derivation of voltage. So, as we observe, the output voltage of regulator is equal to closed loop gain times sum of Zener voltage and base emitter voltage. So, it provides a good regulation at high current, also unlike the simple emitter series voltage regulator. Now we will get an insight of advantages and disadvantages and application of series voltage regulator. Advantages are they are simple to design as they contain the transistors and the Zener diode. Their transient response is fast due to the less components. They are also cheaper due to their simple construction. The disadvantages are they may require heatsink due to heating of transistor. Their efficiency is low if the output input difference is more, that is, we are used where we require output voltage nearly equal to input voltage. They are used exclusively for step down operation, that is, the output voltage is always less than input voltage. The application where they are used are shown. Read and analyze and study yourself how they are used in different applications in the electronics world. Thank you for watching the video. Do give your feedback on the link shown below. Also give your suggestion on the video. Thank you.